Hello everyone, it's a pleasure meeting you all in my mathematics class again. Today let me discuss the problem verification of Green's theorem for the problem integral of over c y to the power of 4 minus 2y into dx minus 6x minus 4xy cubed dy, where c is the given circle, rectangle given as side. They say this is the rectangle and we have to verify the Green's theorem on this rectangle, and the rectangle is having a length of 6 units on the x-axis and 4 units on the y-axis. Let me first give a small explanation on the Green's theorem. The Green's theorem states that integral over p dx plus q dy is equal to double integral over r of dou q by dou x minus dou p by dou y into dx dy. Here this c means that the curve, that is the closed curve that is bounding the region R. Here in this circle you can just rectangle, you can find that OA, AB, BC, CA, CO or the nothing but the curve that is talked about, and the area of the rectangle is the region over which this P and Q are defined, and they have got continuous first order derivative. Now let us come to the problem. Now you see that here we have got this y to the power of 4 minus of something, which I can write it as integral over c of y to the power of 4 minus 2y plus dx. I take that minus on outside. So you see that it is 4x cubed minus 6x dy. Now for application on the right hand side, we require dou q by dou x and dou p by dou y, which I find higher as dou q by dou x is equal to 4y cubed minus 6, and for dou p by dou y is equal to 4y cubed minus 2. Substituting here, you see that it is 4y cubed minus 6 minus 4y cubed plus 2, and on simplification we get minus 4 into double integral, and the double integral runs from 0 to 6 for 6x and 0 to 4 for y, and into dx dy. Either we can say that double integral over dx dy is nothing but the area of the figure in the problem. Here area of the figure is nothing but a rectangle. So naturally the area will be 6 into 4, it is 24 units. Or you can apply the integral and integrate and then apply. Then also we find that in both the cases the area is 24, and hence the right hand side of the right hand side in the Green's theorem is minus 4 into 6 into 4, that is equal to minus 96 units, square units for this particular problem. Now let me try to find out whether let me verify whether the left hand side using the line integral results to the same value, namely minus 96. Now this line integral over c is nothing but the line integral over every length in the given in the rectangle. In the rectangle you can find that it is OA, AB and BC and CO. Now let me come to, so I have written here this integral over c of p dx plus q dy is equal to integral OA plus integral AB plus integral BC integral over BC plus integral over CO. So we have to calculate on all these all the line integrals and sum it up. We should verify whether this value is equal to our minus 96. Now coming to the OA, you can find that in OA y is equal to 0 and dy is equal to 0, and now you apply this y is equal to 0 here. If you apply that y is equal to 0, y is equal to 0 and dy is equal to 0, the whole integral becomes 0, and therefore we find that on OA the value of the integral is 0. Coming to AB, what is AB? It is on AB you can find that it is x is equal to 6 is a constant, and therefore dx is equal to 0. Now applying these values we get double integral over 0 to 4 minus of 36 minus 24 y cubed, taking x is equal to 6 here. So we get dy, and this on simplification and application application of limits, we get 1392. You call it as, so let me call this as number result 2. Our result 1 is the integral value on OA, which is 0. Now on the line AB, the integral value is 1392. Similarly, let me pass on to the integral on the side BC. Now what is our BC? 4, and x is the variable. It varies from 6 to 0, and y is equal to 4 is a constant. Now applying these values, and dy is 0. Therefore you see that on BC, you can just see that on BC it is, now you have to put in the place of x 6, and then you can just see here on the line, you see that y is equal to 4, y is equal to, and dx is the variance, and take y to the power of 4 minus 2y into dx. That is what I have put here. See, you can just see that it is on BC, it is 256 minus 8 dx, which is nothing but 248 of dx, and the limit of x is nothing but on this line it is 6 to 0. So applying the limits, we get minus 1488. Call this as 3. Now let me come to the last integral, namely line integral CO. Here the CO is 0 because x is equal to 0 and dx is equal to 0. When you put x is equal to 0 in the integral C, namely here is dx is 0 and x is equal to 0, because of which the whole integral becomes 0, and therefore call this as 4. Now let us add this OA plus AB plus BC plus BC. Integrals on OA, integral on AB plus integral on BC plus integral on CO. That is 1 plus 2 plus 3 plus 4. This is 1392 minus 1488, which is equal to minus 96a. Minus 96. Call this as a. You will find that this result A is equal to result B, and this result B is nothing but the value of the that is the Green's theorem that we find on the left hand side, namely double integral over r of dou q by dou x minus dou p by dou y. That value is your minus 96, and this A is nothing but the left hand side integral of the Green's theorem, which is nothing but your integral over p dx plus q dy, which is carried out on the sides of the curves bounding the rectangle, on the sides of the rectangle, which is nothing but our A plus C. You can just here OA plus AB plus AB, integral over OA plus A, integral over BAB plus integral over BC plus integral over CO. That is also nothing but minus 96, and thus the Green's theorem is verified in this particular problem.